The Route B bridge is, we've got a state route that goes through the city of Columbia. Kind of takes from the metro section as we get out into the countryside. And what we got here is we're going to take a bridge down, and instead of doing a conventional build where we put in piling, put footings in, columns, and then build our indents, we actually did one where we're going to build what we call like an MSE wall indent. It's a block wall in front of a substructure which has layers and layers of rock with layers of fabric in between to structurally make it tight and strong.
A GRS design has the advantages over a normal bridge structure design in that it doesn't require the heavy equipment that a normal bridge design does. It doesn't require the pile driving, larger cranes for the larger beams and things that you would normally see. It also allows you to do the work in a more congested area, tighter area because of that. It also allows you to get the bridge done considerably faster also because there's not as much additional work to do with a GRS structure as there is with a more traditional design. Contractors can be in and out in a much faster time frame, and in our particular case with our project on Route B, because of the amount of traffic we were dealing with and the road closure we were dealing with, that allows a contractor to get in and get out a lot quicker, which minimizes the impacts to the traveling public. This particular structure, the GRS structure in Columbia, is the first structure that has been built on a state highway in Missouri. This design is not unique to the United States. It's been used in numerous locations throughout the United States, and it's just one more tool that we can add to our toolbox in addressing the great needs that we have for bridge repairs here in Missouri.
It is a layering process. It's meant to be repetitive somewhat in nature, but that is the advantage, is that once you get the technique down, then it's just repeat the steps over, and once you've got that understood, it's fairly simple in that sense of laying a layer of aggregate, packing it, laying a geosynthetic, laying a block on top of that, and repeating that process again at each layer. In general, there's some nuances with corners and with the topping it out and edges and different things, but the general bulk of it is all very much just like you said. It's a layering process where you construct a layer, and then you construct another layer, and you construct another layer until you get to your desired completed height.
Basically, you start from the ground up, you build a drainage system underneath, you put the bridge, then you start, put your wall up, and then behind the wall you start layering it. You put a layer of what we call icing or fabric, then you put your rock in and you compact it real nice and tight, and then you put another layer of fabric, and then you put more rock. And as you get up 2 layers, you put another row of block on the outside, which would be like your outside of your cake. You'd build that up, and you just keep building layers after layer.
It really means a lot, because this means, one, we're going to help the consumers out, our everyday people, where you don't have to have the road closed for 6 to 8 months at a time. This helps construction go faster, whereas APAC can get this bridge done and then move on. Instead of being stuck on a project for 8 months to a year, they can get a bridge like this done in 2 months and then move on to something else. In MoDOT, it relieves the inspectors to move on to another project.
This site was a good site for this application. The bridge is appropriate length, the subsurface conditions are favorable and fairly accessible. Again, it's complicated by some of the urban setting and the utilities, but overall, I think it's a very positive site for us to use for this application.